Okay, in today's lesson we're going to look at double angle results and maybe triple angle results if we get time. So double angle results, it's if we remember from last lesson, I'm just going to write the result for sine of, did we do x plus y? Remember the result for sine of x plus y? So we want to come up with the result for sine 2 theta. Now we know from last lesson that sine of x plus y, do you remember the expansion for that? What is it? Sine x cos y plus cos of x sine of y. Now that's the result for sine of x plus y from last lesson. Okay, now what we're going to do sine of 2 theta, we're just going to let x and y both be theta. Okay, and come up with, or I could do the result for sine 2x, for example. So remembering that sine of x plus y is sine x cos y plus cos x sine y. Remember, sine expansion is keep the sign the same, so the plus has got the plus, and it's the sine cos sine one. Not like the cos one, which is the cos sine one. All right? Okay, so now sine 2 theta is sine of theta plus theta, which is, so we're going to do it the same as that. Isn't that sine theta cos theta, if I'm doing the same as that thing over there, plus cos theta sine theta? Yes? Now I could have done this as sine of 2x actually, instead of theta, but I like thetas. Okay? Are they identical? Sine theta cos theta and cos theta sine theta? They are, because they're multiplied. So I've got two lots of sine theta cos theta. So that is the double angle result for sine 2 theta. So therefore my double angle result for sine 2 theta is sine 2 theta is 2 sine theta cos theta. Two lots of sine theta cos theta. Okay? Now that should, remember we do have on the formula sheet the expansion for the sums of angles, not the differences, the sums. So this one, but they've got theta plus theta, whatever, instead of sine of x plus y. So sine of 2 theta is 2 sine theta cos theta. That's our first double angle result. Now we're going to look at a double angle result for cos. Now, we know that cos, let me just do an expansion for cos of x plus y on the side. Isn't cos of x plus y, isn't that the cos sine one, and it's not keep the sign the same, so the sign will be different. That's cos x cos y plus or minus sine x sine y. So using that result, we're going to come up with our double angle result for cos 2 theta. Now, cos 2 theta, that is going to be equal to cos theta plus theta. That's how we derive it. Think of it as cos theta plus theta. Now, using this result, isn't that cos of the first one, cos of the second angle, minus sine of the first angle, sine of the second angle? How can you write that? Cos theta minus sine theta. Isn't that really just what? Cos squared theta. Cos theta times cos theta is cos theta squared, which is cos squared theta minus sine squared theta. Now that's our first result for cos of 2 theta. It's cos squared theta minus sine squared theta. But there are three results that we use for cos 2 theta. That's the first one. Now, taking that result now and replacing, so that's the first one. And that one's easy to remember because it's cos minus sine. But they just happen to be the cos of the same thing. Is cos theta is cos squared theta minus sine squared theta. Now I'm going to replace cos squared theta with, now I know over here on the side, I know that cos squared theta plus sine squared theta equals 1. So what's an expression for cos squared theta? Isn't it 1 minus sine squared theta? So if I replace cos squared theta with 1 minus sine squared theta, I come up with another double angle result for cos 2 theta. I end up with cos 2 theta is, now I'm just going to start with the first line. Now I'm going to replace cos squared theta with 1 minus sine squared theta. So I replace this cos squared theta with 1 minus sine squared theta minus, and I've still got sine squared theta as well there. So I start with this. That's from my first result. That's my first result. Then I replace cos squared theta with 1 minus sine squared theta. So the cos squared theta becomes 1 minus sine squared theta. I've still got minus sine squared theta here. What do I end up with? 1 minus 2 sine squared theta. So that's my second result, that cos of 2 theta equals 1 minus 2 sine squared theta. So that's my second double angle result for cos. But I could have replaced sine squared theta as well instead of cos squared theta. So once again, we know that cos squared theta plus sine squared theta is 1. So therefore, sine squared theta is 1 minus cos squared theta. So starting with our first double angle result, which is cos of 2 theta is cos squared theta minus sine squared theta, this time I'm going to replace sine squared theta with 1 minus cos squared theta. So in the one above, I replaced the cos squared theta. In this one, I want to replace the sine squared theta. So I end up with cos of 2 theta is cos squared theta minus, now I need to replace the sine squared theta. How do I do that? Bracket, replace sine squared theta, this sine squared theta with 1 minus cos squared theta. I get cos squared theta minus 1 minus cos squared theta. You okay with that? Which is cos squared theta minus 1. Is it going to be minus or plus cos squared theta? Plus cos squared theta. So this is, how do I simplify that? Cos squared theta plus cos squared theta is 2 cos squared theta minus 1. That's my third result. So the cos of 2 theta is 2 cos squared theta minus 1. Now, there's 3 results for cos of 2 theta. If you know one of them, you can derive the other 2. But I do have a little trick for remembering them. So I'm going to write them all at the end again. So these are my double angle results for cos 2 theta. It's cos squared theta minus sine squared theta. That's result number 1. So these are the 3 results. The other one is that cos of 2 theta, I'm going to do the last one first, is 2 cos squared theta minus 1. Oh, it's delaying. I think it will. And the last result is cos of 2 theta is 1 minus 2 sine squared theta. Well, maybe it just wasn't plugged in. So, how do we remember them? Cos of 2 theta is cos squared theta minus sine squared theta. Now, a lot of people get these bottom 2 mixed up, but you know how I think of it as, this is the rule for the double angle for cos. So the cos squared one here is the positive one. 2 cos squared theta minus 1. And because it's the double angle for cos, see how this is positive cos 2 cos squared theta minus 1? And the other one will be the minus 2 sine squared theta. The other one is 1 minus 2 sine squared theta. So the cos one's got the positive cos. And when you do cos of 2 theta is 1 minus 2 sine squared, that's the minus for the sine. Okay? Now we're going to do the double angle result for tan 2 theta. Now, let's just write what we know on the side. That tan of x plus y, and this is on your formula sheet, is, what's this rule? Tan of x, is it the plus one or not? Plus tan of y over 1 minus tan of x times the tan of y. Remember that rule? So now we're going to consider tan of 2 theta to be tan of theta plus theta. Okay? Do the same thing again. Isn't that tan theta plus tan theta over 1 minus tan theta times tan theta? If x and y are the same. So what's that? So it's 2 tan theta over 1 minus tan squared theta. So that's what tan of 2 theta is. So that's our double angle result for tan of 2 theta. It's 2 tan theta over 1 minus tan squared theta. Angle results are sine of 2 theta is, anyone? 2 sine theta cos theta. Cos of 2 theta is, remember it's the cos, sine, sine. So it would be cos squared theta minus sine squared theta. And remember, the reason that the sine 2 theta is 2 sine theta cos theta is you keep the sine the same. So you've got sine cos plus cos sine, which gives you the 2 lots of sine cos. With the cos one, when you do the expansion for the adding, for the addition of the angles, it's the sign's different, which is why you've got the minus in between. And remember, this is the cos rule for the double angle cos. So it's 2 cos squared theta, that's the positive one, minus 1, or it's 1 minus 2 sine squared theta. So there's 3 results for cos of 2 theta. And for tan of 2 theta, remember it would be tan theta plus tan theta, which is 2 tan theta over 1 minus tan theta times tan theta, which is tan squared theta. So these are your double angle results for sine, cos, and tan. Yeah, so you can use, but the thing is you will only use one of them at a time. You would never use 3 of them in one time. So when we come to do some proofs a bit later, or actually very soon, we'll have to do proofs with double angles. You'll see which one fits in best. Okay. So these are some questions from exercise 615. The first question, oh sorry, I think we're starting with question 14. Sorry, question 14. Expand cos of theta minus 2y. Lambda, whatever it is. So first we use our sums and differences. So how do you expand that? Isn't that cos of what? Don't worry about your 2 business yet. So cos of theta, cos of 2y plus sine of theta, sine of 2y. That's like yesterday's homework. But now today, we know how to expand cos 2y and sine 2y. So you can use either one. Let's just do cos squared minus sine squared. Let's just see what we get. So cos of theta is cos, remember cos of 2 theta? Remember our results? Cos of 2 theta, isn't it cos squared theta minus sine squared theta? We'll just use that one. So cos squared y minus sine squared y plus, are we okay with that? We know the result for sine of 2 theta, isn't that 2 sine theta cos theta from what we've just done? So we can replace, so we've got sine theta times sine of 2y is 2 sine y cos y. Sorry, it's a bit small. But we're using our results. So now we can just expand each of these. So that's cos theta cos squared y minus cos theta sine squared y plus, well this is one term now, so it'll be 2 sine theta sine y cos y. They're all multiplied by each other, that's one term. Nothing exciting there. But notice none of the angles are double, like here. So you don't stop here with your double angles. When you see your double angles and you're supposed to expand, you now have to write them in all in terms of single angles. Now you can't do anything with these. There are no, you can't simplify that. Okay? All right, let's look at 14J. Expand this sine 2x minus 2y. Again, we'll use our result for sine. And what's that one? You could, I wouldn't, look, you could factorize out the 2 here, but I wouldn't. It'd be very tricky. So let's just do a normal sine expansion. Isn't it sine 2x? Actually, we might do it 2 ways. We could do it 2 ways. We'll see. Sine 2x cos of 2y, yeah? Plus cos of 2x times the sine of 2y. And that's right, it is, because it's keep the sign the same. Minus. Keep the sign the same. So now we need to write the double angle result for sine of 2x and cos of 2y and cos of 2x and sine of 2y. Fun. That's, do you remember it? 2 sine x cos x. Cos of 2y, we're just going to use the cos squared y minus sine squared y. Minus, let's just use the cos squared x minus sine squared x result. And the sine 2y will use the 2 sine y cos y result. Yes? And now we'll just expand. It's not looking very nice, is it? At the moment, it doesn't matter which of the 3 double angle results for cos that you use, because we're not trying to do a formal proof. I suppose we don't, it's not saying expand and simplify, but if we did then further expand, we would just expand out each bracket. But I'm pretty sure that we are not going to see, the only time you would then expand is if you think that you may be able to cancel some terms. But then we've got minus cos squared x times that, so that's going to be minus 2 sine y cos squared x. And what about the next one? So it's minus, see, I could write that in front. The next one will be a minus or a plus? It's plus 2 sine y cos y sine squared x. Now I'm pretty sure nothing cancels, and it doesn't. So there really was no need to expand again, because you can't simplify. 2 cos 3x sine 3x. Which result could this come from? Sine 2 theta, cos 2 theta, or tan 2 theta? Now I know you have a 3x in place of something else that you'd like to have, but we know that sine of 2 theta is 2 sine theta cos theta, right? Yeah, right? What was if I replace the theta? So see these thetas? Instead of theta, sorry, it's not very big. Instead of theta, you seem to have the right-hand side, but theta is replaced with 3x. Yeah? So if you replace theta, if theta equals 3x, you would have sine of 2 times 3x equals 2 sine 3x cos 3x. Agree? That's what you've got. You know, look, I know the cos is before the sine, but it doesn't matter which order things are multiplied in. This is definitely the double angle result for sine. So that looks similar to this. 2 sine theta cos theta is sine of 2 theta, but let me tell you, theta is rarely ever going to be theta. So in this case, in our case, the theta is replaced with a 3x. If theta is replaced with 3x, that's definitely what we have. So I have to replace the theta here on the left-hand side with 3x. So what does that become? Sine of what? 6x. So that equals sine of 2 times 3x, which is sine of 6x. Okay? So you've got to recognize where it's coming from. Now, just think of all your double angle results. So all of these, when you see the sine coses and this 1 minus 2 sine squared, they're all from the double angle results. But this sort of looks like a double angle result, but it's not quite. There's something wrong with it. What's it missing? It's the sine one. It's not the cos one. The cos one is cos squared minus sine squared. Well, we know that 2 sine theta cos theta is the sine of 2 theta. Do you agree? That's what we know. We normally write it the other way around as well. That's the result that we know, that sine 2 theta is 2 sine theta cos theta. But this question doesn't have the 2 in the front. So what do? Divide by 2. The format that you've got is sine theta cos theta. So what do I do with the 2? Divide. Now that's the format you've got. But in your question, you don't have theta. What do you have in place of theta? 6 theta. So, but we're going to replace theta with 6 theta. Okay? So therefore we've got, so I can see over the side, I'm just going to replace my thetas. My thetas have been replaced with 6 thetas. Do you get it? So you need to do this working out on the side. So therefore, what have I got? I've got the sine of 2 times 6 theta. Are you okay? Because the theta is going to be replaced with the 6 theta. over 2. So sine of 6 theta cos 6 theta would be sine of 2 times 6 theta, sine of 2 times 6 theta divided by 2, which is sine of what? 12 theta divided by 2. Don't go and divide this 2, please. Oh, actually, sorry, that has to go like that, because it's sine of that whole angle. So please, I need brackets there. Actually, I'm going to fix this here. I didn't write that up very well. Sine of 2 times 6 theta, because it's sine of 2 theta. It's sine of that full angle. Okay, so it's the sine of 12 theta divided by 2. Okay, now for h, do you recognize this one? We know that that's got to be one of our cos results. We know that the cos of 2 theta, isn't it 1 minus 2 sine squared theta? That's looking pretty good. It's correct format. What's theta being replaced with? 40 degrees in this case. Yes? So what does your thing equal? So 1 minus 2 sine squared theta is cos of 2 theta. So just replacing the theta with a 40 degrees. So what does this equal? Cos of 2 times 40 degrees, which is the cos of 80 degrees. Now the last one, I don't recognize that at all. So, what do you think you should do? Expand and see what comes out of it. Ready? This is a minus b squared is a squared, which is sine squared 3x, minus 2 times a times b, minus 2 sine 3x cos 3x. So a minus b squared is a squared, minus 2ab plus b squared. That's what we're using. So plus what? Cos squared 3x. Now, sine squared 3x plus cos squared 3x, they can be grouped together. What do they equal? Minus 2 sine 3x cos 3x. Now, I know it's 3x, but it's sine squared of this angle plus cos squared of this angle. It really is like the following result. Sine squared theta plus cos squared theta equals 1. So if sine squared of something plus cos squared of that same angle are added together, what do you get? 1. So all of that equals 1 minus, now 2 sine 3x cos 3x, isn't that just like 2 sine theta cos theta? That equals sine of 2 theta. That's what we're using. And in this second bit, isn't just the theta replaced with what? 3x. So it'll be 1 minus, so I'm going to replace that whole thing with sine of 2 times whatever theta is, minus sine of 2 times 3x. How we do that? Which is 1 minus sine of 6x. Find the exact value of this expression, 2 tan 15 over 1 minus tan squared 15. So double angle result, you know that this is the tan 2 theta result is 2 tan theta over 1 minus tan squared theta. So what's your theta in this case? 15. In this case, tan is 15, theta is 15. See? 2 tan 15 over 1 minus tan squared 15. Beautiful. So this is really the same as tan of what? 2 times 15, which is the tan of 30 degrees, which is 1 on root 3. Okay? Now, they're not all that straightforward. The next one. Sine of 67.5 degrees, cos of 67.5 degrees. It's definitely not coming from the tan result, and it's not coming from the cos result. It's coming from the sine result, but it's not quite right. We know that 2 sine theta cos theta is equal to the sine of 2 theta. But you don't have the 2 in front. All you've got is sine theta cos theta. That will be sine of 2 theta divided by 2. What is theta in your case? 67.5 degrees. So that's our little working out on the side. make sure we don't mess it up. So you've got sine of 2 times 67.5 degrees divided by 2, which is the sine of, what's that, 135 degrees divided by 2. Now, we're using our 2-unit stuff. Sine of 135, which quadrant? 2. Am I interested in 135? No. I'm interested in the acute angle in that quadrant. The angle touching the x-axis. Is sine positive in quadrant 2? Great. So it's just really the same as sine of 45 degrees over 2, which is 1 over root 2 divided by 2, because it's sine of 45 over 2, which is 1 over root 2, that's divided by 2 over 1, which is times 1 over 2, which is 1 over 2 root 2, which you can rationalize it, okay, by multiplying by root 2 over root 2, which is root 2 over 4, rationalized. Exact value for 1 minus 2 sine squared 165 degrees. This is the result. 1 minus 2 sine squared theta is what? Cos of 2 theta. Not squared, cos of 2 theta. So in this case, theta is 165. So your 2 theta, you can even do it over here. 2 theta is 165 times 2. Is that 330? Yeah. So you can do all your little bit of working out on the side. So that really is the same as the cos of 330 degrees, because I've worked out, well, the theta's got to be 165. The 2 theta here is 330. So cos of 330, all stations to central. 330 is here. It's quadrant 4. The acute angle is 30. Is it positive? So it's really just the same as cos of 30, which is root 3 on 2. Okay, this last one, which we'll double angle for sine, cos, or tan. So double angle for sine. 2 sine theta cos theta equals the sine of 2 theta. Yep, looks exactly like it. In this case, theta is 105, so may as well work out what 2 theta is over here. It's 210. So it's in the correct format. So therefore that is equal to the sine of 210 degrees. All stations to central puts, well, 210 is in quadrant 3. 30 degrees into quadrant 3. Sine positive or negative. So it's negative sine of 30 degrees, which is negative a half. And if sine of alpha is 3/5 and tan of beta is 12 over 5, find the sine of alpha plus beta. Well, we know we have to draw 2 different right angled triangles because you've got 2 different angles, alpha and beta. So let's go. We're lucky they're both Pythagorean triads. So sine of alpha is 3/5, so that's opposite over hypotenuse. So what's the missing side? It's, what's your triad? 3, 4, 5. Missing side is 4. By Pythagoras' theorem. And tan of beta is opposite over adjacent, which is 12 on 5. Do you know your other triad? It's 5, 12, 13, but we'll just work it out. X squared is 5 squared plus 12 squared, which is 169, and so x is 13. And this one, we know 3, 4, 5 is the triad. Okay, so your other one is 13. I'll put that in there. Okay, off we go. So sine of alpha plus beta. Actually, that was very much like yesterday's homework. So that's pretty much like what we did yesterday. So it's sine alpha cos beta plus cos alpha sine beta. So you've done ones like that. Okay, sine alpha we know is 3/5. Cos beta means, let's go to the cos triangle. The beta triangle, you've got to do cos beta from there. That's 5 over 13 plus cos alpha is in the alpha triangle, which is 4/5. And sine beta is in the beta triangle, which is 12 over 13. Looks like we've got a common denominator of 13 times 5, which is 65. And the numerators appear to be 15 plus 48. Is that 63? 63 over 65, I'm hoping. The cos one, cos of 2 alpha, there are 3 equations that you could use. I'm going to write them over here. Cos of 2 alpha is 1 minus 2 sine squared alpha. You know that one? And we know what sine alpha is, so we could do it in one step. Or you could use cos of 2 alpha is 2 cos squared alpha minus 1. Or you could use cos of 2 alpha, tell me what the other one is. Cos squared alpha minus sine squared alpha. Now, the only one of those that does not require additional work, would not even require drawing up the triangle, would be the first one. So I'm going to do it 3 ways. So cos of 2 alpha. If I did use 1 minus 2 sine squared alpha, it would be 1 minus 2 times 3/5 squared, which is 1 minus 2 times 9 over 25, that's 18 over 25, which is 7 over 25. That's one way of doing it. Look, most of you will probably go to the cos squared minus sine squared, right? That's what probably most of you would do. I'll just do it that way as well. Cos of 2 alpha, or could have done it like this. Cos of 2 alpha is cos squared alpha minus sine squared alpha. Now cos alpha is 4/5. So it's 4/5 squared minus sine alpha was given in the question, minus 3/5 squared. So you could have done it like that too. Now that's common denominator of 25, 16 minus 9, again 7 over 25. Now the other way I could have done it would be to use the 2 cos squared alpha minus 1, but I'm not going to do it that way. You can see already 2 different ways to do it, but there were 3 because there are 3 results for cos 2 alpha. And I'll just do this sine 2 beta 1. We know that the double angle result for sine 2 beta is 2 sine beta cos beta. So you must sit in the beta triangle to do this. So 2 sine beta cos beta. Sine beta is 12 on 13, cos beta is 5 on 13. So it's 2 times 12 on 13 times 5 on 13. The denominator this time will be 169, and you need to multiply 120. 120 over 169. And part D, you did do ones like that in your homework yesterday. That's not a double angle result, that's just an ordinary sums and differences. Tan alpha minus tan beta over 1 plus tan alpha tan beta. And we can see from our diagram, just make sure you're using the correct triangles. According to the triangle, tan alpha is 3/4. Tan beta is 12 over 5 over 1 plus tan alpha is 3/4 and tan beta is 12 on 5. Now be careful, I want to do this one just to be able to simplify. What is the lowest common denominator? 20. So we're going to multiply through both the numerator and the denominator by 20. So multiply the numerator by 20 and the denominator, but there are 2 terms on the numerator. So timesing this by 20, what's 20 times 3/4? 3/4 of 20. 15 minus 20 times 12 over 5. That would be 48 over 1 times 20 is 20 plus, well, you just lose the denominator here if you times that by 20, plus 36. See how that's nice? So that's negative 33 over 56. Okay?